I always forget that I have to hit the go live button inside the YouTube control panel. they gotta make that a little bit more intuitive. But anyway, let's see here. Oh yeah. All right. Let me know how the audio sounds. Make sure that background music is not too high. Definitely let me know what your predictions are while we're waiting for the actual live event to start happening. I got a buddy that's at CES right now. He said that the line for this event was crazy. So, yeah, that's. He said the line to get into the event was crazy. He said he had to go back to his room, and I definitely plan on being at CES next year. Yeah, for sure. Definitely plan on being there next year. But let me know what your predictions are down in the chat. What do you think? You think that the 5090, hey, what's going on down in the chat? You think that the 5090 is going to be 2000, right at 2000, 2500, or will we break a cap? Hey, what's going on down in the chat? I appreciate y'all. Welcome. Man, I'm excited. Technology has been a little bit crazy, you know what I'm saying, for the past year. And it's definitely, we're back to being excited about technology again. So this is dope. I can't wait. But I definitely want to know, like, what are your predictions? You know what I'm saying? Like, what do you think that I know we had a lot of leaks, a lot of rumors. Yes, Byron, for the 5090, do you think, now I know we've already seen some, and I think I may be able to pull it up here. So let's do this. So I know, like, so far, like on video cards, they've already been showing the, I think they showed the actual 5090. I posted it in the Discord earlier. But I think they actually showed something and that said that it definitely had like 32 gigabytes of VRAM, which is crazy, by the way. But we still don't know what the pricing is going to be. So Byron, you say that the Founders Edition, you're thinking for the 5090 is going to be $17.99. You know what? That's actually pretty good, because what did the let me see, the 4090 came out at what's $15.99. So $17.99, $200 more. I can see that. I can see that happening. Because with tax, you're really pushing up on that 1,900, 2,000 mark. So I can definitely see that. 5080, you think it'll be $14.99? That's QDOV down in chat. I'm hoping that it's not $1,500. If anything, maybe $1,300. You know what I'm saying? But who knows? Byron, you think the 5080 Founders is going to be $13.99? That's possible. Like I said, I'm thinking $12.99 for the 5080, because that leaves a gap. So if the 5090 is around, let's say the 5090 is $1,800. If they do the 5080 at $1,300, that leaves a gap for them to release like the Super and the TI variant. So you could kind of meet somewhere in the middle. So they'll probably sell maybe like a Super or TI variant for maybe $1,500, you know what I'm saying, or $1,600, somewhere along those lines. But looking at the actual the gaps in performance, I don't know. If everything stacks up like what we think it's going to be for the 5090, I'm trying to find the article that I saw earlier today. If everything stacks up though, I'm thinking let me see. I'm thinking maybe we'll be in a situation where I'm trying to find an article. If I can find an article that I was using earlier in a Discord, then it could give me all of the specs, well, the quote unquote potential specs. But yeah, we got about, I thought we had a countdown, but we got about 7 more minutes until the event starts. But I feel that they will drop the 5080 once the 5080 Super will be 14. Yeah, that's true too. They're like, oh, here we go. Is this it? I think this is the article I was looking at earlier. So in this article, I'm just looking at this gap in performance, and why I can't zoom in. I don't know why. Oh, here we go. So I'm just looking at this gap in performance, right? So 5090 potentially CUDA cores. We're talking about over 20,000, which is like double that of the 5080. So it definitely leaves a slot for maybe like a 5080 Ti, 5080 Super, or something along those lines to maybe have 15,000 CUDA cores, probably 24 gigabytes of VRAM. I'm telling you, if this holds true, the reason why there's such a gap right here is because they're going to release a second set of cards. And so it's going to be interesting. I was hoping that if you haven't seen my video that I posted here, AMD Keynote, I talked about this. I had a few gripes. So definitely check out that video. But there was parts in here where it's like everybody was thinking that they was going to talk about at least their new mid-range GPUs, but they didn't talk about them at all. So it was kind of crazy. But we need competition, that's for sure. G-Tech down in the chat, 5080 Ti, 24 gigabytes. Yep. Yeah, I honestly believe that. That's why they upped this to 32 gigabytes. Man, you're talking about 512-bit memory bus. And look at this memory bandwidth. We're talking about almost 18 gigabytes. Ooh, that is crazy. Not too concerned about the power and stuff like that, because that is what it is. But man, yeah. I said, okay, Byron, you say 5080 Super / Ti, 20 gigabytes, maybe 24, as you mentioned, but in the reserve. Yeah, and I was thinking about 20, but then I'm like, I don't know, See, overseas, there was some variants of like the 38. Was it a 3080 or a 4080? Maybe it was a 4080, but they had a possibility of like 20 gigabytes of VRAM. But I'm thinking the way that the architecture is set up, they'll stick with either, 32, 24, 16. I just can't see, even, they don't talk about the 5060 series, but like with games today, you really can't go below 12 gigabytes. Like 8 gigabytes is not going to cut it. So it's going to be interesting to see what all they announced today. I heard some ramblings about there being some new texture compression that would kind of help out with the VRAM, but that's not the only thing that VRAM hits hard. The path tracing and frame generation also requires more VRAM. Now, will you be doing that on the lower end cards? Probably not, but it just options, right? So we got a few options. So I'm excited though. I'm definitely excited. We got about 4 more minutes. So yeah. Man, let me tell you something. Yeah, if they do a 5080 Ti, 24 gigabytes, $15.99. I don't know. That's a good sweet spot, actually. Most people won't need a 5090. Even the 4090 was more powerful than what people thought it was going to be. The performance of that card is still crazy. But the newer games with the path tracing and stuff like that, like if you're trying to max out a card, you got a 4K high refresh rate monitor, you're trying to do everything that, like, take a game like Black Myth Wukong. you could play that game 4K without ray tracing, no issue. But as soon as you tap in on the ray tracing with the, maxed out settings and all that different type of stuff, yeah. So it is what it is. And Byron, I haven't been able to set up the voice chat. But I know you have some admin rights. So if you are able to set that up and people want to jump in, you definitely can. I probably won't be able to jump in based on the actual stream. I'm listening to like 2 different things at one time already right now. But Byron, if you want to, if you want to head that off, you definitely can. It's going to be interesting to see what new technology that they talk about. So I've been hearing ramblings about DLSS 4. Hopefully they don't do what they did last time and they gate kept frame generation to the 4 series. Hopefully that doesn't happen this time with whatever new technology that they have. So yeah, definitely like, subscribe, and hit the, hit the bell so you receive all the notifications. And also join the Discord. All the links are in the description below to be able to do that. So definitely make sure that you do that. And yeah, it's almost that time. And I'll make sure I definitely turn up the audio once the event starts. And we got about 1 minute. So let me go ahead and just make that full screen. And I will make myself smaller here. I don't want to cover up anything as far as the event. So but yeah, I'm thinking, even though I got a 14900K, and it's crazy fast. I got a 7800 H3D, but depending on these new cars, I think it's going to be time to upgrade the CPU again, which is crazy. I know earlier in the Discord we was talking about the 9950X 3D and the 9800X 3D. I know a couple of people in the Discord already had a 9800X 3D, so it's going to be interesting. And we should be starting right about now. And just so y'all know, I am streaming in 4K. So the best, they are also streaming this in 4K as well. So yeah. So if you're not watching in 4K, definitely make sure you're watching 4K. Yes, sir, Byron. I already know, man. AMD has been rocking it with the CPUs for a long time now. So, definitely. Hey, Byron, I know you like that LG C4, but let me tell you, this is a ASUS monitor, and I got a review coming real soon about my ASUS monitor. I've been testing out a lot of things and making sure I really understand everything about it. And yeah, the PG32 UCDM, amazing monitor. Oh yeah, the 7800 H3D is smoking when it comes to gaming. So yeah, if you don't need more cores, then you good, man. Definitely good, especially with the 3090 Ti that you got. So let's go, Nvidia. Let's go. Let's get it rocking. It's 9:32. Eastern Standard Time, that is. Like I said, I got a buddy, and I forgot his YouTube channel. He has a YouTube channel. It's Danny Tech. But he's actually at CES right now. He was telling me he's watching this back at his room. He said the line to get in was like crazy. So, I was kind of turning it down a little bit. But yeah, he said that the line to get into the event was crazy. So maybe they're still trying to seat people. Probably is what's going on right now. I don't know, but I want to hear all the technology, prices, the new stuff, and hopefully, again, Nvidia doesn't gatekeep everything to just the new cards. Like, I can understand certain stuff that's just from a hardware level that's incapable. But, it'll be interesting to see what they do this go around. So, oh, the Asus monitor model, it is, I'm going to type it in the chat. It's the Asus ROG PG32 UCDM. I think that's right. And they just announced a 27-inch version with the newer panel, but a lot of the reviews said it's just the same as the 32-inch. Oh, here we go.
CES isn't just about what's next. It's about what's possible. And when technology and humanity intersect, the answer is anything. That's because tech doesn't just solve challenges. It transforms them into opportunities. It helps us move smarter, live healthier, and experience the world in ways we never thought possible. We are not just here for a tech event. We're here to connect, to solve, to discover, together. Tech isn't just advancing, it's uniting, bringing us closer to an autonomous future, connecting us to better care, making life more connected, more dynamic, and more human. Today's challenges demand bold solutions, and CES is where they start to take shape. Breakthroughs in sustainability, advancements to help feed our growing world. This week isn't just a stage for breakthroughs, it's the spark for discovery. Every screen, every pixel, every part of the tech you will see here showcases the extraordinary potential of human ingenuity meeting technological power. Now we begin this celebration of what connects us, has the power to solve our greatest challenges, and offers endless possibilities we're yet to discover. Right here, right now, the world is watching. So let's dive in.
Ladies and gentlemen, welcome to CES 2025. I'm Gary Shapiro, CEO and Vice Chairman of the Consumer Technology Association, the producer of CES, and I am so thrilled to kick off this show with a keynote by one of the most consequential companies in the world. Nvidia exemplifies the cutting-edge innovation we celebrate at CES. And founder and CEO Jensen Huang is a true visionary, demonstrating the power of ideas, technology, and conviction to drive innovation and reshape our industry and our society. I always like to say that if I'd listened a little bit more closely the last time Jensen spoke at a CTA event, I could have retired already. But over the past 3 decades, he has established Nvidia as a force driving change across the globe in industries ranging from healthcare to automotive and entertainment. Today, Nvidia is pioneering breakthroughs in AI and accelerated computing that touch nearly every person and every business. Thanks to his leadership, Nvidia's innovations enable advanced chatbots, robots, software-defined vehicles, huge virtual worlds, hyper-synchronized factory floors, and so much more. Wang has been named the world's best CEO by Fortune and The Economist, as well as one of Time Magazine's 100 most influential people in the world. But you know, the fact is, like for all of us in this room, our success and his success was not preordained. Jensen started out working at a Denny's as a dishwasher and a busboy, so be nice to them in the future. And he said that the lessons he's learned there, the value of hard work, humility, and hospitality, are what helped him keep the faith and persevere through some of NVIDIA's early challenges.
Y'all think Jensen
In
gonna
just a
show
few
up in the
minutes,
kitchen?
we'll hear from
It'd
NVIDIA
be good to
founder
see him
and
in the kitchen
CEO
again.
Jensen Huang on his unwavering vision of the future and where we're headed next. Stay tuned and have a great CES.
Goodness gracious, look at all those people. Oh my gosh. My buddy wasn't lying. There's a lot of people there.
Please take a moment to sanitize your devices. Our event is about to begin.
Man, Jensen is definitely wearing that jacket. I can tell y'all that now. That's a signature move for him. He's wearing the jacket. The question is whether or not are they gonna do something maybe like an AI generated background for him, showing that he will be in the kitchen, something crazy, something slick. I know they got something up the sleeve, so it's gonna be interesting. You know, I wonder why they had these long pauses in between though. So they got something cooking, no pun intended. And you know, in terms of the kitchen reference, that's definitely a lucky jacket. Yeah, that jacket is smooth. The jacket probably got AI in it. Man, Nvidia, come on with it. The anticipation is driving me nuts. And they're about to have people selling their kidneys, left leg, right arm for their 5090. All right, here we go. Yeah, I'm a kind of. They got that music playing in the background. I don't really want that a part of the stream. Any more predictions before they get going? You think they're gonna release the 5080 first or the 5090 first? Definitely let me know. There have been rumors that said that they're going to release the 5080 first. I'm hoping that's not true. I'm actually hoping, I know we've seen boxes that showed that the 5080 was going to have 16 gigabytes. I was actually hoping it was going to have more. My 4070 Ti that I use in my streaming PC has 16 gigabytes. So it's kind of weird that you have, but again, Nvidia likes to segment their cards, so that either that TI super variant hopefully is going to have a higher VRAM amount. So we'll see. But I'm starting to believe like the 50, 80 or the 80 series of the cards are starting to become mid-range per se. I hate to say that, but it seems like that's what's happening. Come on with it.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, the first step into an extraordinary
you're
world
probably right.
where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Tony, light up.
Thank you, Adam.
And give us peace of mind when we need it most.
Hi, Maroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
Oh, no, that's wild.
They bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life.
That's
and
the
restore
technology
what we've
right there.
lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time. And one giant leap. Together. And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
There you go. Yep. There goes that jacket. That look a little different this time, though.
Welcome to
what's that? Is
CES.
that gator, snakeskin? What is that?
Are you excited to be in Las Vegas? Do you like my jacket?
Is that velvet?
I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it. Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin.
He definitely extra
And
drip.
we're going to take you
He definitely
to
does.
NVIDIA. Ladies
So
and
that
gentlemen,
jacket about $5,000.
You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called
Yeah, Brian, you're right. We did. We helped. We definitely
missing the
helped.
letter C until a little while later. But UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain.
Yes, this is live.
And it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are
So right now, he talking to the investors right now. Bring it on, man.
This fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
Following footage is rendered in real time using RTX Blackwell. Okay, y'all, I want you to pay attention. It says DLSS 4. If you was paying attention. RTX neural materials, 16 megabytes of memory. Standard material, 47 megabytes of memory. So that neural DLSS transformer. I see what they're doing. Oh man. This neural stuff that they're talking about, DLSS 4, I bet you it's only going to be available because they said that this is being rendered on Blackwell, which is the new architecture. Yeah.
That was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating three additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2.
Oh, man.
It is an absolute miracle that we can computationally,
technology is crazy,
computationally using programmable shaders,
but
and
they are definitely going to link this to the 5000 series.
To compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation the RTX Blackwell family. Let's take a look.
Yeah, that price point is about to be crazy. That 5090 is gonna be about $2,500. Ooh, 2-slot design. That's an angled connector. They put the fans at the bottom, so they redesigned the card. High density PCB, 3D vapor chamber. G7, 1.8 terabytes bandwidth. Oh, this is the 5090, y'all. Let's see. No, they did make the 5090. That looks like the 5090.
Here it is.
Looking at the specs.
Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors.
Is it 2 slots?
4,000
It's a 2-slot card. Oh boy.
4 petaflops of AI. 3 times higher than the last generation
It's
Ada.
big, but
and
it's a
we need
2-slot
all of
card.
it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron.
That memory
1.8
bandwidth
terabytes
lines
per
up with what
second,
we just looked at on
twice the
video
performance
cards
of
at
our last
1.8
generation. And we now
terabytes.
have the ability to intermix AI workloads with computer graphics workloads.
G-Tech,
And
$3,000.
one of the
You might be
amazing
right,
things
man.
about this generation is the programmable shader is also able to now process neural networks.
The PCB
So the
is definitely
shader
short.
is
It's
able to
super
carry
short.
these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell.
I can't see what it says.
5090.
Oh, he said 5090. Okay, so that is the 5090.
Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big.
It's in the
The
middle.
voltage regulated design is state of the art.
I think the chip is in the middle this
Incredible
time.
design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds. So how does it compare? Well,
Here we go.
this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your
People laughing about their best investments.
$10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled.
He's selling it. He's selling it right now.
Fancy lights all over
Thing
it.
about to be about $2,500.
You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549.
Did he just mistakenly say that the 5090 was going to be
Impossible without
$1,599?
artificial intelligence.
Did I hear that right?
Impossible
Let me know
without
down in the chat.
the 4 teraops of AI
The 5070
tensor cores.
being $549 is
Impossible
good
without the
because
G7
they
memories.
released the 4070
Okay, so
at $600.
5070, 4090
So
performance.
$549 is not bad.
And here's the whole family. Starting from 5070 all the way up to 5090.
Oh, there it
5090,
is.
twice
It's
the performance of a
$2,000.
4090.
Damn.
Starting,
Ooh.
of course, we're producing at very large scale, availability starting January.
58 is
Well,
$1,000.
It is
That's
incredible,
actually
but we
really
managed
good.
to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. I think there's one here somewhere.
Hey, the
Let me show you
AIB
this.
car is going to be $2,500. Just want you to know.
This is a,
Oh, they charge
look
you.
at this thing. Here, here. There's only so many pockets. Ladies and gentlemen, Janine Paul. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense?
Now,
Well,
we all know.
you can't do that without artificial intelligence.
We all know laptops, the equivalents are not the same as the desktop variant. So, yeah.
We ray trace only the pixels we need.
The 5080
generate
for
using artificial
$1,000,
intelligence all of the other pixels we have. As a result, the amount of the energy efficiency
it's actually pretty good. But I'm definitely going to buy me a 5090.
is neural
I don't know when yet,
fusion of
but it's going to happen sometime this year.
And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay? So, ladies and gentlemen, the RTX Blackwell family.
Hey, the FP cars are going to be hard to come by for the next few months. That's for sure.
Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at NVIDIA. This is literally our office. This is literally NVIDIA's headquarters. Okay, so let's talk about AI. The industry is.
All right. While Jensen is talking about AI, I just want to go ahead and just plead my case right now of why you should donate to the channel. I got to get a 5090. So if you like what you're seeing so far, definitely make sure that you help a brother out on the super chat or, PayPal. The links are down in the description below, but help a brother out. We're going to go ahead and start this fund right now for the 5090. Go ahead and start putting them decks to the side because, I need to get one.
And the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think
that is a $400
years,
increase on the 90 series card, by the way.
Will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand. Maybe proving a theorem, maybe solving a
Byron, go ahead and get the
geometry
5090, man.
problem.
Get
So
that 32
these
gigabytes of
problems,
VRAM.
would cause the AI
Which
to
they really
produce
didn't talk
answers,
about
and using
either.
reinforcement learning,
So maybe that's
it
coming.
would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate, your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better
Yeah, I hope we don't have any more issues when it comes to
of course,
the
is the most valuable asset that we have.
the
and it can
connect
be
and
applied
melting.
to solve a lot of very challenging
Thank God
problems.
I never ran into that issue, and
So, scaling
and
law.
still hope I don't.
It's driving enormous demand for NVIDIA computing. It's driving an enormous demand for this incredible chip we call Blackwell.
Man, I want to hear.
Let's take a
Jesse,
look at
you talking a
Blackwell.
lot about the AI,
Blackwell
but I want to hear
is in
more about
full
the gaming
production.
performance.
It is incredible what it looks like. So first of all, there's some, every single cloud service provider now has
I know he has to
systems
sell all the features,
running.
but
We
I
have
want to
systems
hear more
here
about
from
this
about
gaming
15,
performance. That's what I want to know about.
15
How much
computer
faster is the
makers.
5090
It's
over the
being
4090?
made, about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that Janine?
You looking like, girl, what you doing? Good God, I'm about to look at that silicon.
It's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second. Is this a good idea? All right. Wait for it.
Yeah, I agree. If the leap is
Wait
like
for
what
it.
it was from the 3090 to the 4090, we thought that was like a 50-60%
I thought I was
increase.
worthy.
It's crazy. I'm thinking it may be. This is a whole new
Apparently,
architecture.
Yoni didn't think I was worthy.
We got
All right.
GDD R7.
This is my show and tell.
VRAM.
This is a show and tell. So,
The
this
CUDA cores is
NVLink
crazy.
system, this right here.
I need
this
to know,
NVLink
though.
System, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars.
It's crazy.
120 kilowatts. It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems.
Nvidia stock about to explode.
And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant
5070
chip.
will give you 49 performance, and that is crazy. Which makes me believe, G-Tech, what you were saying.
If we would have had to build
I think that performance increase, because that's what they were saying about.
Sorry, guys.
That's what they were saying about the 3070 Ti over the 2080 Ti. It was giving the same performance. In the 40.
If we had to build this as
4070
one chip,
Ti
obviously this would be the size of the
was
wafer,
giving the same performance as a 3090, I believe. So yeah, that might be right.
But what we
I think that's
basically
right.
have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer.
You know, as much as I don't like Nvidia when it comes to like the pricing versus performance on the low end, that 5070 is going to give 4090 performance for 549. That's actually legit. I'm not going to lie. That's a good move, like for real.
Petabytes per second. That's basically.
So ain't no way that's ain't no way it's that good. Man, I don't know. I don't know.
The entire
I think
internet traffic
what they're not saying is that at what resolution. I can't see that being the case at 4K, but I can see that being the case at 1440p, which is probably what they're targeting. So we'll see. We'll definitely have to see. I definitely can't see that as a case at 4K. 4K gets a little bit more difficult. So we'll have to see about that one.
Networking chips.
Hey Byron, I appreciate that deal that you gave me on that 4090, man. Oh man.
Okay. And these are all of the HBM memories. 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can, thank you, thanks.
Yeah, people they're gonna be selling the hell out their 4090s. They're gonna be like, man, it's like, I learned my lesson. I'm not selling no more of my graphics cards. I actually still have my 3080 Ti. I gave it to my daughter though. For school.
Can I have a Michelob Ultra?
I got a 4090 in my main gaming PC, 4070 Ti Super in my streaming PC, which is also another gaming PC.
How is it
And
possible?
I'm just going to keep collecting from there on.
Michelob Ultra Stadium. It's like coming to Nvidia and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator. And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well,
I got a question for y'all. Did y'all see how Jensen started creating new terms about AI? Hey, innovation at its finest.
Integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are
exactly, Byron. I'm trying to.
Algebra or doing fluid
we've been talking a lot about
future,
AI. I want to see gaming performance.
Acceleration
Just show us some new
libraries,
games, something.
Acceleration libraries, we'll have
Please.
AI libraries. We've created 3 things for helping the ecosystem build agentic AI. Nvidia NIMs, which are essentially AI microservices all packaged up. It takes
If they don't get a 4000 series DLSS4,
CUDA DNN,
I'm going on a strike.
Tensor RTLM or Triton,
For real.
all of these different really complicated software, and the model itself, we
I'm
package
lying.
it up, we optimize it, we put it into a container, and you can take it.
I'm lying like a big dog.
And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud, because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI
Man,
agents
Jensen trying to get rid of the HR departments in these companies. Oh my
language
God.
of your company, maybe the vocabulary is unique to your company, the business process is different, the way you work is different. So you would give them examples of what the work product should look like, and they would try to generate it, and you would give a feedback, and then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline.
Down in the chat, do we have any programmers?
Is called NEMO.
Any programmers down in the chat? Just let me know.
Department of every company.
Because it seems like this is where the future is going.
Department of AI agents in the future.
AI programming.
Today they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the Nvidia Llama Nemotron language foundation model.
Yeah, I agree.
Llama 3.1 is a complete phenomenon.
The technological leap that we're going to have is about to be crazy.
Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not. Basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work being done at ServiceNow, at SAP, at Siemens for industrial AI.
Now I see why AMD did their keynote earlier today. This one is a little bit boring. There's more exciting information, but
really fantastic stuff.
AMD couldn't hold a candle.
Every software engineer in the world.
They're still growing in their area.
Next giant AI application, next giant AI service period is software coding. 30 million software engineers around the world.
Told y'all.
Everybody is going to have a
software coding
assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we created and some of the work that we've done with our partners with these AI agents.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. Nvidia's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at Nvidia, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And Video Analytics AI agents, built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here, for every organization.
Okay. That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI was created in the cloud and for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud, it's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have, in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is 2 operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. It's been WSL2 has been optimized.
WSL2.
Optimized for cloud native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to
So basically what he's saying is that it's not only just gamers that we have to fight against trying to get these cards, but it's going to be programmers, AI, large language models, all type. Everybody's going to be trying to buy these cards, and especially the 5090 because it's going to have the highest VRAM.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you.
Man.
Linux is good.
Can we see some gaming performance?
Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective. Computationally demanding.
G-Tech, you're exactly right. He is definitely running. He running it up. He running up the scoreboard for the stop. Gaming is definitely last. This is painful.
Bring it back. And instead of what is produced,
the nerd side of me is like, man, this is so cool. But also the the gaming enthusiast side of me is like, show me some gameplay, show me some comparisons, sell that part, and yeah, it's coming up last.
Of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you, poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create a world, we need a world foundation model. Today we're announcing a very big thing. We're announcing Nvidia Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. Nvidia Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an Nvidia CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use Nvidia Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, Nvidia is helping advance the next wave of physical AI.
Nvidia Cosmos. Nvidia Cosmos. Nvidia Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated this model
Did he say
understands
do a
this
Doctor
model,
Strange?
and also,
Okay, Jess.
could do, of course, captioning. And so it could
What
take
about
videos,
gaming?
caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the Nvidia Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open.
Come on, Jensen.
We really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics grounded system.
They're gonna really make me change my whole career
to Cosmos,
over into AI and robotic programming.
that can control and to condition the
I'm not lying.
generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA of robotics. So let me give you 3 examples. All right, so the first example is
Jensen, give us an example of gaming performance, okay?
To industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically it's the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Keon, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have through the developers and ecosystem partners. And we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that, this one example that we're doing with Keon and Accenture.
Keon, the supply chain solution company. Accenture,
Okay.
a global leader in professional services.
While they're going through this, the boring stuff right now, let me know down in the chat, what do you plan on getting? I need to hear from everybody. Do you plan on getting a 5090, 5080, or 5070? And do you plan, let's say today, if they release at the end of this month, do you plan on copying right away, or are you going to wait a little bit? Let me know. I definitely plan on getting the 5090 as soon as possible. Can't say when just yet. Yeah, because I don't plan on selling any of my graphics cards, so I'm going to be buying from scratch. And that $2,000 is that's a steep climb. It's definitely a steep climb, but we're going to never say never. But let me know down in the chat, what do you even plan on? Knowing what we know now, 5090 is $2,000. 5080 is $1,000. Did they show the 5070 Ti? Because on this video card thing, they saying $749. I just remember seeing the 5070 for $549. So Byron down in the chat, you saying that you're gonna wait until mid-year for sure. I feel that. Yeah, I definitely feel that. I feel that. I don't know if I'm gonna be able to wait that long. Everything definitely has to line up for sure, though. I will say that.
Can simulate infinite scenarios at scale while measuring operational KPIs such as throughput.
I can't believe they went this long with talking about all this boring stuff. This is crazy. Let me see. What card? I'd like to get a 5080 Super Ti. Or if things go well and they are around that time, I might get a 5090. 5090 Founders Edition only. Definitely. Yeah, I don't know if I'm gonna get another AIB card when it comes to the high end. Now I do like my 4070 Ti Super. I got the tough version of that. I do like that for sure. Super quiet card. Looks good too. But for the 5090, Founders Edition all day. Yeah, because them AIB cards, you're right, Byron, they will be $2,500 or more. Easy. I mean, the 4090 recently was, going for like $2,000. So for the AIB cards, so I already know. Another $500, $2,500, close to maybe 28, easy. Synthetic data generation systems, Omniverse, and now Cosmos, and also the computer. Easy on that one. Let's see what else he's talking about.
Might work with us in a different way, use 1 or 2 or 3 of the computers. We're working with just about every major car company around the world. Waymo and Zoox and Tesla, of course, in their data center. BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with Nvidia starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and Nvidia are going to partner together to create their next generation AVs. Just so many cool companies. Lucid and Rivian and Xiaomi and, of course, Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora We announced this week also that Aurora is going to use Nvidia to build self-driving trucks.
Oh, yeah. 5070 Ti is
100 million
$749.
cars built each year.
I don't know if that's worth the
billion
extra
cars,
$200.
Vehicles on the road all over the world. 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion.
I will say this, if you're not following me on social media, definitely check me out on Instagram. That's where I'm the most active. Also TikTok. Don't know how long TikTok is going to be around, but definitely Instagram, Twitter X. Y'all know what it is.
And this year, probably on a run rate
And Discord.
So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer.
And see, that's what you do as a CEO. You already selling the next generation.
Amount of sensor information.
Crazy.
Process it,
I ain't mad at them though.
umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a human or robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, NVIDIA CUDA, yep. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of
man, y'all think he gonna show any gaming performance? He may not. I don't know.
I'll show you some of
We got to ride this one out and see. But so far, it's been about AI, which I should have known.
And use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers. Nvidia DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. Nvidia's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability.
Hey, Bobby, down in the chat, you said anyone feel like they're suddenly in the Matrix? Yeah, man, I feel you. We've been in the Matrix for the past hour. Okay.
Incredibly exciting time. Super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. I think the next part is robotics. So
the next part needs to be gaming performance. I'm gonna be real with y'all. They showed us DLSS 4 and didn't show us no rasterization performance. Good God about it. They showed us DLSS 4. I don't, this really makes me kind of think. The fact that they didn't talk about any rasterization performance is an issue, because now I'm starting to think maybe we won't see such a big leap. If they're going to lean on DLSS 4, which is upscaling technology, I don't know about that one. They've been leaning real heavy on this AI neural generating, like pixels and not just frames. So we're not just generating frames, now we're generating pixels, and yeah, I don't know. Because he said something specific about if there's 33 million pixels, the card only did the heavy lifting on like 2 or 3, which is crazy. So it's generating like all this different type of stuff. And I'm like, how much rasterization performance are we going to see? That's the question. Like, the hardware on paper looks good, but I don't know. I don't know about that.
We think that the robotics era is just around the corner. The critical capability,
G-Tech, based on the benchmarks they just released on the website, raw performance, ain't gonna be that much. Yeah, because I'm sitting here looking. I'm on Video Card's website, and they just talked about DLSS in neural rendering and generating like new stuff.
Hundreds of demonstrations, thousands of human demonstrations. And
you know what? Hold on a second. G-Tech, hold on a second. Because they not talking about nothing right now. Hold on a second. Let me go back here. Let me see something.
And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
I just saw something else.
Developers around the world are building.
He said it's looking spooky out here. Yeah, they talking about robots and shit. Let me see. There's I don't know which article I'm on. Oh, I'm on a DLSS article. They do have is this it right here? Yeah. So look, so they're talking about, I hate these ads keep popping up. So DLSS off, right? And did they say what card that they were using? So DLSS off 27. Since DLSS introduces multi-frame generation, this is probably Cyberpunk with path tracing. Probably, I don't know. Because I'm looking at that frame rate is yeah, it's crazy. But then DLSS 2, 3.5, and then 246. Yeah. But here's the problem though. Look at this. So at 4K 240 hertz, it's up to 8 times the performance with DLSS 4. And based off, and this is with a 5090. So based off of what Jensen said, we're talking about
Next, they use GroupGen, built on Omniverse and Cosmos for domain randomization.
A lot of this stuff is going to be generating the actual frames and the pixels. So
the Omniverse and Cosmos multiverse simulation.
I'm wondering, hold on, I'm trying to read the fine print. So GeForce RTX 5090, 4K resolution with path tracing where applicable. RT Max using the Ryzen 7 9800X 3D, an Asus X870E Creator Pro Art, 64 gigabytes of DDR5, DLSS 4 multi-frame generation. So now they're okay. 4X mode. I don't know what that means. Super resolution, performance. So they're using performance mode on the upscaling. They're using ray reconstruction where applicable, which is Cyberpunk. So DLSS 4 performance-wise is pretty much going to be almost twice the performance of DLSS 3. But that's all about frame generation. They didn't talk about anything about rasterization. And that's the problem. You know what I'm saying? Like, that's the problem that I'm running into on this. So it's almost kind of like they're trying to circumvent. We may have hit a wall when it comes to rasterization performance. We may be in a situation where we just can't hit it without all of this software, unless Nvidia is using the actual software to circumvent the optimizing games. So I don't know. It's interesting.
We wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer.
DLSS 4 will launch with support for 75 games on day one. It will fully support all RTX 50 series GPUs, while the RTX 40 series cards will utilize single frame generation technology. Oh, the bullshit starts. Okay. Yeah. What's the difference in between? See, reading this right here, the 40 series cards will utilize single frame generation technology instead of the multi-frame. You see what they call this? DLSS 4 is multi-frame generation technology. So it's generating the frames along with the actual pixels and the scenes and everything. So it's doing a lot more generation, but they haven't said anything about rasterization. So just keep that in mind. You gotta read through the bullshit. So yeah, it's gonna be interesting to see what happens.
So, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this.
Yeah, G-Tech down in the chat. The devs are definitely going to get much lazier when it comes to making games. So instead of them, they're going to rely on leaving it up to the AI software to generate the scenes, not just the frames, but the scenes, the pixels, and the textures, and all this different type of stuff, instead of actually baking that into the game. So, yeah.
110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside.
Okay, this is NVIDIA's supercomputer. I got something else I want to show y'all because that's boring. Take a look at this. So you see this line here. It says that DLSS will launch with support 75 games, while the RTX 40 series will utilize single frame generation technology. Take a look at this. So DLSS 3, which is what we currently have with the 40 series, you have a regular rendered frame, you have DLSS super resolution and ray reconstruction, and then it generates a frame, which is part of DLSS 3. So optical flow accelerator, then DLSS frame generation. But the Blackwell cards, the 5000 series cards, is going to use multi-frame generation. So we're talking about the same thing that was happening here. This is still DLSS 3, but this is the new stuff. So it's going to generate 3 frames instead of 1.
All right, so imagine this is what.
So, yeah. And then this is also going to have a DLSS transformer, which is a little bit different. So it's going to generate more. And this is where the performance boost is coming from. Instead of it generating 1 frame per 1 render frame, is going to generate 3 frames per 1 render frame.
This is what it looks like. And
Yeah. That's what it's doing.
With ConnectX, and it has nickel.
So this doesn't say anything about rasterization performance. It's all about frame generation.
It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. 1 amazing AI world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such, and 3 robotics. 3 robots. We're working on agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please.
You know, I just thought about something else as I was sitting here reading on VideoCard's website. The 5070 Ti is actually looking a lot more, depending on the actual VRAM, that may be a good move with DLSS 4. Definitely a 5080, but that 16 gigabytes of VRAM is not. If that 5080 only comes with, so Byron stated earlier down in the chat that if they bring out a 5080 Ti or a Super, that might be the move with like 24 gigabytes plus the DLSS 4. You'll get more performance than a 4090, but then you'll get the actual DLSS 4 with the generation. I still don't really like, I still want to see rasterization performance, but they're definitely going to gatekeep DLSS 4 multi-frame generation, that part, to the 5000 series.
Happy New Year. Thank you.
So yeah, he's done. Okay. So, yeah, I mean, yeah, it was good. It was good. Yeah, it was good. So, all right. Going back to, so let me know what y'all think down in the chat. You know, where did this satisfy your craving to want to know more? Were you surprised about what you saw, or were you a little bit disappointed? Let me know down in the chat or in the comments if you're watching this at a later date. I'm, you know, the more and more I started reading, and, you know, like, they didn't give us any, they didn't announce any new games. They didn't show everything was pretty much software related when it came to the technology side of things, which is a little bit disappointing because that means that I think this is really like the first time, because, okay, they talked about, you know, like even when the 40,000, I mean, the 4000 series came out, they talked more about gaming. They didn't spend the whole time on gaming. You know, they did talk a lot about AI and stuff, but this time it was like they came up with new terms for AI, different evolutions. It was all about AI, and it was like, oh yeah, this thing also games as well. But again, like we saw some of the slides. If I go back, where is it? So we saw some of the slides. Again, if you didn't hear what I was talking about earlier, DLSS frame generation, DLSS 3 is what we currently have right now, which is, you know, included with that is frame generation. So a regular frame is generated. You have other technology, which is DLSS super resolution and ray reconstruction. That's a part of that, mainly used in Cyberpunk, and it's also used in some other games. But with the frame generation, it generates one frame for every one frame that's rendered. And part of that is optical flow, and it generates. Okay, cool. Now, but DLSS 4, which we read a little bit earlier, is going to be limited to the 5000 series. I think we kind of knew that from a standpoint of the multi-frame generation. So I believe the 4000 series is still going to get DLSS 4, but not the multi-frame generation part. And so the multi-frame is for every one frame that's generated, it's going to generate 3 frames, which is going to boost the amount of, you know, performance per se, and it's really not real performance. The interesting part about this is that now it's generating 3 frames for every one frame that's being generated. So the stability of the image that's being generated is probably going to be a lot more, you know, a lot better than what we experienced with DLSS 3. I will say that. But the most interesting part about this is that again, they didn't talk about rasterization. It's all about generating what the developers want us to be able to see, instead of them baking that into the actual game and for it to be optimized for your hardware. down in chat, G-Tech, I'm wondering if the 57 actually equals the 49 raw performance. I don't think so. I think they are heavily dependent on DLSS 4 to match that performance. And this has kind of proved it. So I believe the people who have a 4090, you actually are pretty, you're in a good space. I'm going to keep my 4090. And I think I'm just going to wait until we see independent testing before I even make a bust a grape. You know what I mean? Because the thing about it is that even on the heavy games right now, if Nvidia is leaning on DLSS, I mean, we already have frame generation. It's not one game right now. Once I turn on frame generation, you know, that I can't run in 4K, you know what I'm saying, and maxed out settings. Not one game. And I have a 4K 240 hertz monitor. It's not one game where I'm not getting the performance, even with the new stuff that's coming out. If we're dependent on frame generation, then I mean, this is, I may wait well, I can't see myself waiting a generation, but I don't know until I see some rasterization performance to see what the big difference is. Because if it comes out to, from a rasterization standpoint, that we're only seeing like a 15% increase, that means that the next generation of GPUs is actually going to be where it's at. So that's the part that I'm struggling with right now. Let me know your thoughts down in the chat and then, and in the comments below what you think. Did we get handed something that was just full of crap? Because again, you have to read the fine print. It's GeForce RTX 5090, 4K resolution, path tracing with applicable, RT Max, ray tracing max. So max settings, they're using a 9800X 3D. And they're showing you the difference in between having DLSS off, then DLSS 3, which is what we currently have right now. And I want you to pay attention because they don't tell you what these numbers here on the left-hand side are, but these are probably frames. You know what I'm saying? I don't know. Could be, maybe not. They don't tell you, so you just got to test it for yourself. But definitely, a lot of this stuff is really not making sense. And they're using performance mode when they're using this. So these are probably frames on the left-hand side. I would guarantee it. So, because we're talking about Black Myth Wukong, performance mode with path tracing. I don't get that high, but I definitely get up into the hundreds. So they're using a 9800X 3D. That might be right. I'm thinking these are frames on the left-hand side. So, because with frame generation, performance mode, when I play Black Myth Wukong with path tracing, ray tracing, everything maxed out, cinematic mode, I'm still getting like 100 and some frames per second with frame generation. So with a 9800X 3D, that frame rate increases because you're maxing out the card. So I may put my money into another processor, really, instead of another graphics card right now. So I'm going to have to really think and ponder on that one. Training game, I also have to wonder about the potential bugs and issues with the multi-frame. Exactly. Because there was some teething pains, when it came to DLSS 3 frame generation. Sometimes the image, wouldn't come out right because it was throwing another frame in with the render frame. So when it was in motion, you really couldn't really tell. But if you went back and you actually, if you recorded something at 120 frames per second, and you actually slowed it down, you could see sometimes the image would break apart. But, that's when, if you was pixel peeping, you know what I'm saying? But with this, it's generating 3 frames. So that's what I'm saying. It may work out. It may work out because they do have some games that they said that was going to be available. So these games include Alan Wake 2, Cyberpunk, Indiana Jones, Star Wars Outlaws. Will be updated with native in-game support for DLSS multi-frame generation. 50 series GPUs at launch. Black Myth Wukong, Marvel Rivals, Microsoft Flight Generation will soon follow. Black State, Doom, and Doom Awakening will launch with DLSS multi-frame generation. So it's not a lot of games. They said, so I thought I read something about it. It said 75 games support day one. So maybe they just listed these. So I don't know. Yeah. So it's just something to think about. I don't know. We definitely need to, we have to take this one with a fine grain of salt, people. Again, I appreciate y'all for rocking with your boy. We've been going for about 2 hours strong now. I am definitely going to call it a night. I got work in the morning. But again, we can follow this chat over into the actual Discord. Make sure that you hit like, hit subscribe, hit the bell so you receive all my notifications. I appreciate y'all for, again, rocking with me, and I will see you all in the next video. Peace. I'll holler at y'all later.